right, guys. Any questions on any of the assignments so far? So what we're doing today isn't something completely brand new. We're talking about composite functions. Y'all have done these in Algebra 1, or you've done these before. And what we're doing is we're working from the inside out. We're just working from one function into another. Now, the way that I remember these and the way that they were mentioned when I learned them is we talked about them as fog and goff. Because where we write a composite function like g of f of x is the same as saying g of f of x. G of f of x. Well, this here looks like goff, G-O-F. And we talk about fog, which is f of g of x. Again, it looks like fog. And these here represent, because f of g of x is f of g of x. And goff is our g of f of x. And we work from the inside out. So we start with f of x, plug it in, and then go to g of x. And the same is true from g of x to f of x. And when we look at these functions here, so this one, f of g of x, f of g of x. Now, I talked about this last week, and it seemed very odd when we talked about f plus x, f of x plus g of x, and I said, okay, we're plugging x into f of x. And that's really what this here we're doing at the start, is we're going to start in the dead center. We're going to start all the way inside and work our way out. So the first thing we're going to do is plug x into g of x. Well, I'm just replacing every x with x. It's not really doing anything at the start. So most of the time when we start these here, we're just saying I'm replacing g of x with what it's equal to. And here g of x is which now gives us f of x squared plus 3. Well, I know what f of x is. F of x is x plus 2, yes? But I don't have f of x anymore. I have f of x squared plus 3, yes? I replaced x with x squared plus 3, yes? So that means in the function, everywhere there's an x, I'm replacing it with x squared plus 3. So what we have is x squared plus 3, because we replaced that x, and then we have plus 2. And every time we replace that x, replace that variable, we put it in there with parentheses. Because if here it's just x, if it had been negative x, we still need that negative sign, and then what we're replacing x with. Yes?
So would that only be if it was gx, right?
Either way.
If it was just x?
So here, because if here it's f, so we're looking at the function f of x, yes? So if it had been g, we would be looking at the function g of x. And we'll do g of x here in a second. We'll do the other way around here in a second.
Then how do you get x squared?
Because that's our,
Okay.
because we're working from the inside out. So we replaced g of x with its function first. Because realistically, we're putting x into, we replaced x with x. Really doesn't change anything. So we ended up getting the x squared plus 3. Now we're replacing x squared plus 3 for every x, and we get this here. Now, since we don't have anything outside the parentheses, there's nothing being multiplied by those parentheses. We didn't have 2x multiplying it by 2. We can really just drop the parentheses and then combine like terms, which would be our 3 plus 2, which is x squared plus 5. And this here is our f of g of x. And that's it. That's all we have to do for this here. Any questions on this here? So now we're going to look at the function g of f of x. So this time we have f of x on the inside. So we're replacing x with x in the function f of x. It's really not changing anything. And what is f of x? X plus 2. So I'll replace our f of x with what it's equal to, x plus 2. Any questions so far? Now I don't have g of x anymore. I have g of x plus 2. So in the function g of x, I'm replacing every x with x plus 2, which would give us x plus 2 squared plus 3. And this is a good reason for putting those parentheses around it, because if it's 2x, it's going to be 2 times what we're replacing the x with. Well, we need to simplify this. We're not going to leave it as x plus 2 squared. Well, x plus 2 squared is the same as x plus 2 times 2 plus 3. Now our x plus 2 times x plus 2 would give us what? Because we'd have x squared plus 4x plus 4, yes? And if you can see that multiplication from x plus 2 times x plus 2, go on and write that out. Now if we worked it out step by step, distributing the x times x is x squared. X times 2 is going to be plus 2x. 2 times x is going to be plus 2x. And lastly, 2 times 2 is plus 4 plus 3. Now, if you saw that the x plus 2 times x plus 2 and can see that that's x squared plus 4x plus 4, go on and write that. You don't have to do the 2x plus 2x if you see how it does multiply. But here, if we multiply it all the way out, we get our 2x and 2x, which do add together to be 4x plus 7. And this is our g of f of x. Questions on this here? Was that the same as f of g of x? Well, what was f of g of x? X squared plus 5, yes? Is x squared plus 5 and x squared plus 4x plus 7 the same thing? No. So are these two functions the same? No. And for the most part, not always, for the most part, f of g of x is not going to be the same as g of f of x. For the most part. There are a select few functions, there's a select group of functions that these actually are the same. And if it does work out these are the same, it's going to equal x. If they are the same, it's going to equal x. And we'll dig into this and exactly how they actually equal x tomorrow when we start talking about 5.7. We'll do one more of these here with these composite functions. When I say one more, go in f of g of x and g of f of x. And these here are actually easier than what we just did. Any questions on this here before we start this one? Now, in the last few, we went on and started this off by writing f of g of x, yes? We don't necessarily have to rewrite it because we're taking f of g of x, yes? What's g of x? If it was me, I'd go on and just start here. Go on and replace g of x with what it is. Because g of x is our 2x minus 4, so I replace it with 2x minus 4. So now we're looking at the function f of 2x minus 4. So we're going to replace 2x minus 4 with every place x is in f of x, which would give us the cubed root of 2x minus 4 plus 1. Do we have anything in front of those parentheses that we need to apply through the whole thing? No, there's no negative sign. There's nothing being multiplied. There's nothing squared. So realistically, we can drop those parentheses and combine like terms. Negative 4 plus 1 is? That's it. Because there's no way to simplify that radical. The only way that we could simplify it is if the 2x minus 3 was to the third power, or we could write it that way. But the degree is 1. I can't just add powers to it without changing the overall function. That's it. Questions on this here? G of f of x. Well, I'm going to start out with g of. We could write f of x at this point and then replace it. Or we can just go on and replace f of x with its function, which is the cubed root of x plus 1. Then what would we have next if we plugged the cubed root of x plus 1 into g of x? And then have the minus 4, yes? Because I'll put it in parentheses because we are multiplying it. Well, if the radicals were the same, we would multiply what's inside, yes? Does 2 and the cubed root of x plus 1 have the same radical? Well, no, we're just multiplying. So this here is going to be 2 cubed root of x plus 1 minus 4. That's it. Because if they did have the same radical, we had 2 cubed roots being multiplied, we'd multiply what's inside. That's it. Questions on this here? Y'all starting to remember some of these here, doing these before? Let's look at one last one just so we can see the distributive property. Do we want to look at this one or the next one? Same function, it's just saying f of g of x or g of f of x. This one. So f of g of x. Well, what's our g of x? So we're going to take f of 3x plus 5. Now our f of x is 2x plus 7, yes? Yes. So we'll replace the x with 3x plus 5, giving us 2 times 3x plus 5 plus 7. Now at this point here, we'd have to distribute the 2. 2 times 3x is 6x. 2 times 5 is, we have a 6x plus 17 is our f of g of x. And that's it. Any other questions on these here? Evaluate the composite functions. Now, when we did this with addition, subtraction, multiplication, and division, we figured out what the function was, like we did with the last few, where we found out what f of g of x or g of f of x is, and then plugged the number in. Did y'all remember doing that yesterday, where we had to work out what it is, and then plugged it into the simplified form? We can absolutely do that with these here, but there's not a whole lot of reason to. Because again, as I said at the start, for these here, we're working from the inside out. So let's work from the inside out for this here. F of g of 3. Well, the farthest inside is g of 3. So we're going to plug 3 into g of x, which is going to give us f of 3 squared plus. So all I did was plug 3 into g of x. Now this here looks like it might get complicated because, well, we could then plug this into f of x. But I'm going to do one step in the middle. Three squared plus 2, is all of that a number? Well, that's simplified to a single number. Yeah, 11, because 3 squared is 9, plus 2 is 11. So when we do these evaluating, I'm going to take it from the inside out. So we started by plugging 3 into g of x. Simplify that to what its value is. Here it's 11. Okay? Let's do it again, but now instead of g of x, we're using f of x. So we're going to plug 11 into f of x, which will give us 3 times 11 minus 4. And since we've used the last function, because we would have removed our f of x, the f part here, because when we plugged it into g of x, the g is gone. We've applied that function. Here we just applied the f of x function. And we can simplify it. 3 times 11 is? So f of g of 3 is 29. That's all we have to do. Questions on this here? Bless you. Let's look at one more, because I don't think we need to look at more than one more of these, because I think y'all like these. Yes? Compared to everything else we've done on here. So here we're looking at g of f of -1. So again, the first thing we can do is plug -1 into f of x. If we plug the -1 into the f of x function, we get 3 times -1 minus 4. Yes. Now the 3 times -1 minus 4, we could plug that into a calculator and let it simplify it for us. Or if we did it by hand, 3 times -1 is -3, minus 4 is -7. Okay, now we're going to evaluate the g of -7, which will tell us that we have -7 squared plus 2. Exactly. It's 51. Because our -7 squared is 49, positive 49, plus 2 gives us 51. And that's it. That is our g of f of -1. Questions on these here? Any other questions on any of these here with evaluating? We'll get a little, especially, I know on the review, I don't know so much about the test. I think there might be one where I will give you one such as f of g of something like this here. But again, we're still working from the inside out. So for this here, we'd start with g of 6. Well, we plug, because again, working from the inside out. So we're plugging, evaluating g of 6 first, yes? Well, that would be the absolute value of 6 plus 5. What's the absolute value of 6? 6 plus 5. So f of 11. So we'll plug it in there. So it's going to be negative 2 times 11 plus 3. Well, guys. Yeah, because all we're doing is just what we did on the previous one, but instead of, because here we did it twice and we're done, yes? So all I'm doing is again and again and again. So it's not,
We don't need all these lines.
no, I was just throwing that up there as an example because I put that on the review sheet because again, this here is not bad because this here we're doing it in the simpler form to kind of so that you get familiar with the concept and understand it. This one here I just threw up there because on the review sheet, this here is digging deeper into the same concept. Even though we have the function repeated, we have function repeated multiple times. We're still doing the same thing. We're still working from the inside out. We're not going to try to tackle all this at once, but we look at the dead center, the g of 6. And then we look at the f of 11 and go from there. Because then it would be 2 times negative 11 is negative 22, plus 3 is our negative 19. And then we're going back to g of x and plugging negative 19 in. And what we get out of that, we'll plug into the f of x. What we get out of that, we'll plug back into g of x. We'll come back to it, but this here isn't any different than what we just did. It's just, we're just going back and forth, putting it into each one. Yeah. Now, there's one last thing I want to look at. I just want to look at one of these here, just so we see it with the negative. Yeah. Example 5. It should be the first one that's example 5 at the top. Should be at the top of one of the pages. Okay. So we'll look at the f of g of x. Now for us here, g of x is what? So we're looking at replacing g of x with what it's equal to, 2x minus 4. Questions on this so far? So if I want to apply or find f of 2x minus 4, I'm replacing every x in f of x with 2x minus 4, which would give us 2x minus 4 to the negative 1. Now, mathematically, we can't leave it like this because we can't have a negative exponent. We can't leave it with a negative exponent. But for this one time and on the homework, I will take that. We can leave it as this form here, and that would be the answer. That's all we would need to do. We're not going to delve into domain, what the domain of this is, because when we talk about the domain, we're looking at the restrictions of how the composites work with each other. And that gets a little more complicated than it absolutely, well, it's more complicated than what we want or I want to dig into here. And most likely, there's a good chance you might not even see this come back up in college algebra. They might cover depending on the professor and what they choose to cover and the depth they choose to cover it. But we're not going to focus on that. One of the assignments does ask to state the domain. I don't want it. You don't have to put it down. Yep, we're just going to I just want you to find the composite. So for the second half, I think it's 25 through 28. It's for those it says find each composite and state the domain. I just want you to find the composite. So this here would be our f of g of x. And if we wanted to look at this one here, our g of f of x, well, our f of x in this function is x to the negative 1. And then if we plug this into g of x, 2 times x to the negative 1 minus 4. And if we multiply these two, it would just be 2 times x to the negative 1 minus 4. And that would be the function, that would be the answer we would take. I would take for this one here, and I would take on the homework for here g of f of x. Now, if it worked out that the exponent became positive, that's fine. You don't have to go about making it positive in that rewriting it as 2 over x minus 4. Because this would be the mathematically correct way to write this, because again, we can't have negative exponents. We would need to bring it down. But for the homework for this assignment, we're taking this here. Mainly this, but it would be good to have this, especially if it's asking for more than one on the same problem. You don't have to convert it this way here. Now, if one of them said for problem 13, find f of g of x and g of f of x, it wanted both for that same problem, then it's good to have that down to distinguish between the two. But I believe most of the problems are going to be kind of written that way. 17 is f of g of x, just wants 1. 18 is g of f of x, it's just wanting the 1. Then we don't need to write it. But that's all we're going to do for this here.